So far what we have seen how a database is created. We as a data engineer were creating database for Imarticus where certain tables needs to be created and certain relationship needs to be maintained. Now first of all, so far what we have seen, how does a DDL commands works, what are the different DDL commands, and now over here we have created one table known as students table based on the data types which we can use in SQL and the constraints which were there. When we were studying about the constraints, now what are constraints? Constraints are nothing but the rules and limitations which you can implement on the type of data which you need to store into your tables or into your database as such. But when we were studying constraints, the two of the major important constraints which we are going to revisit and understand in a more elaborative manner is primary key and foreign key. Now, what is an importance of a primary key and foreign key in a table? Why primary key foreign key relationships are so important and how it can help you to maintain the flow of data in a proper manner. Let's try to understand that today, and let's see how both of them would be able to create a relation for the same. And when a relation is created, what are the necessary requirements which needs to be maintained when a database structure is being created with a relational database management system. So let's study and talk upon the first important constraint amongst the primary key and foreign key, nothing but a primary key. Now if you can see, this was a table which we created, and let me just create another basic one for the same. So imagine that I had a table which we created over here named as students table. So the table was named as students and it has certain columns, or I can call it as fields or attributes within it. So what were the columns? If you can see over here, there was student ID, student name, age, city, phone number and gender. So let me create that. Let's say student ID, student name, age, city, gender and phone number. So these were the columns which we created into the students table. Now what is a primary key? Which column do we think so a primary key could be created? Over here when we created a table, we created students ID as a primary key. Now what was a key requisite of a primary key? Let's understand that in detail. Why? Because when we create a relation, the primary key understanding is very important. So first of all, if I want to talk upon a primary key, now primary means one and necessity or an important key into my table or into my database management system. So when I talk upon primary key is a combination of something called as not null, which means it cannot consist of null values, plus unique, which means if the values are filled, all needs to be what? Unique. Now not null means it's mandatory, and unique means each value should be different from the another. So primary key is a combination of not null and unique. And why do you think so? Primary key is created into a table. A primary key add uniqueness. It adds uniqueness. What is the meaning of adding uniqueness? That it makes sure that each record into the table is different from the rest. So that is how uniqueness is required over here, and primary key will help you to get that particular aspect. Now one of the major thing which you all need to focus is only one column can act as a primary key. Now there could be many columns or many attributes or many fields into your table which can behave like not null and unique, which can add uniqueness, but there should always be one primary key into your table. Now let's see how. The database which I have to create is an Imarticus database, and in that so far I have created one table named as students. With this students table, there were certain attributes such as student ID, student name, age, city, gender, phone number. I created student ID as a primary key. I have given my reasons earlier, but let me talk about it more detailed. So what is that? Student ID. Now student ID of a student. Imagine me joining as a student in Imarticus. So let's say my ID is 101. Let's say my ID is 101. My name is Jagrati. So my name is being stored over here. Let's say my age is 25. So it's being stored over here. City states as Mumbai. Gender is female. Just understand it. It's Mumbai. And the phone number, I give some random number over here. That's being passed. Imagine there is one more student who is coming into the Imarticus database and her name is also Jagrati. Let's say her name is also Jagrati. Her age is 27. She is belonging from Pune and the gender over here is female and her number is something different. Imagine that. Now, she can't get the number which I have, which means I being a ID or I being a student, I have got a number as 101 and I am one entry. Now, this is another entry and this number or this student is getting an ID of 102. If you can see, 101 and 102 both are different from each other. Now, what is the meaning of that? That means this student and this student is different from each other. Each record is different even though the name seems to be what? Same. That is one point. So primary key helps you to add distinctiveness or uniqueness into your table. Now you will always say that why can't a phone number be a primary key? Obviously, phone number can also add uniqueness into the table. Each student or each individual can have phone number which is different from the another one. That could be possible. So why I am just thinking of student ID as a primary key? First of all, my first assumption over here, whenever I have to choose any column to be a primary key into your table or into my table or any of the table as such, is it should always follow a rule of not null. Now, not null means I know that each student who enroll into the organization or into the student database is going to have some or the other enrollment number or unique ID which is there. Now imagine today I am going on Amazon and I have created one ID on the basis of one email ID. Tomorrow I have that ID generated. I have that customer ID generated for them. Let's say I am trying to create another account with the same mail. It will give you error. Why? Because that same mail has been used, has been utilized. They will say that customer ID is generated for this particular mail. You have to use that customer ID. So as you can see, each customer is going to have different IDs. So similarly, when new student join, each student is going to have different student ID over here. So not null, which means each of the student is definitely going to have ID. There is no students without ID. Not null is being satisfied. Now I cannot keep student name. Why? Because I know student names can be kept mandatory, but they cannot be unique. Why? Because as you can see in my table, Jagrati and Jagrati, there are two students with the same name and that's ideally possible. None of us is having distinct name from the another one. There would be n number of students or there would be n number of people with same name. So not null as a constraint could be satisfied with student name but unique could not be able to. Why? Because none of the individual is having unique name from the another one. So that column acting as a primary key is ruled out. Student ID is still into the list. Now let's talk about age. Imagine my age is 25. The other student who is sitting beside me is 27. Now there is one more student who enrolled and his or her age is also 25. Now it's not following the rule of uniqueness because none of us is being having or none of us is being consisting of unique age from the another one. So that not null could be possible but unique could not be possible over here. City, same reason. Now multiple people or multiple students can belong from the same city over here. So it could be not null but uniqueness would be ruled out. Now gender, as you know, male and female, these are the two criterias. That gender could only be male, it could be only female. We cannot have uniqueness over here. Phone number is still into the list. in order to act as a primary key, because each individual I know is going to enroll from a different phone number. But what if student is not having any number? He will keep it blank at certain instances. He will keep it empty, or some of the students might repeat phone number of individuals. That could be possible, but that is at a very odd instances. But phone number might not be a mandatory part to be there at certain instances. Why? Because some of the students might not have a phone number or a contact detail, and that might be kept as blank. There are possibilities in future to be that way. So what I could do is, I have two columns which can act as a primary key for me. One, just a second, one is student ID and one is phone number. I know when I'll create a different table, definitely there will be student ID preceded, which means if I want to allocate some course, I will allocate on the basis of student ID which is generated, not particularly on the basis of phone number. Now, if I want to generate or if I want to create the score sheet of that particular individual, definitely I will use student ID at a very rare, very particular instance instead of phone number. So, I can think of this column as a primary key. Why? Because I can create relations with this key from the another table. I can make it as a primary key, but as you know that only one column can act as a primary key over here. So I can keep it unique plus not null, which means I can add two constraints over here and make it one. But as per the rule of primary key, it should be one column in the table which is there. So if I want to add uniqueness to each row or each record over here, I'll definitely choose a student ID. So each student ID is referring that each student is a different record from the another one, and that's why I have chosen student ID as a primary key. Now there are many instances where you can choose phone number as a primary key in order to create relation. There can be mail IDs as such, or there can be other instances or other columns which might act as a primary key. Now you have to further inspect your data very clearly, very effectively, and then make sure that which column to act as a primary key. Why? Because primary is important and it is always going to be one in a table, and over here my student ID is going to act as a primary key. Now why a primary key is created? Now always everyone has a question, and I have answered the question that primary key makes sure that each entry is different from the another one, which means it adds uniqueness or distinctness to your record set or to your data set, which makes sure that records are different from each another. And that was about the primary key which we created. So I hope you understand what is a primary key. You can create one primary key in your table, but unique and not null constraints could be added to n number of columns into your table. But you have to be sure when you're applying constraints that when to apply and what to apply over here. Now, why do you think so? A primary key is created, and what is the purpose of a foreign key related to the primary key? Let's understand that. Now, one more thing to discuss about over here is whichever table has a primary key associated with it, it is also known as a parent table. Parent table. Now what is the meaning of parent table? Parent table is a main table from where the information could be related. But there could be multiple tables where multiple primary keys, means there are 4 tables. So the 4 tables can have 4 primary keys, each in one of the tables. So which table should act as a parent table? Which table should act as a child table? Let us understand that as well over here. So I hope we are clear till here, and I'll be erasing this detail because I'll be requiring it for the further go, and I'll help you understand that why I'm erasing it. So I've kept it empty. This is what we have created so far. Now let me talk upon a foreign key. So let me talk upon a foreign key. Now, what is the meaning of the word foreign? You must be knowing. Foreign means someone from outside. Yes. So foreign key is a key which comes from another table, or which helps you to make relation with the another table. That is a foreign key. So foreign key is used to create relations. Now foreign key. What is a foreign key? Foreign key is a foreign key is an attribute. Now you must be knowing what is the meaning of attribute. Attribute means nothing but a column name. So a foreign key is an attribute or a set of attribute. Now what is the meaning of set of attribute? Set of attribute means multiple columns. So foreign key is an attribute or set of attributes which helps to create references, References means a relation, references within the tables. So this references would be created within the table. Just a second. Within the table to maintain. Now this word is very important. To maintain. To maintain what? To maintain a word, which is very important in terms of foreign key. That is nothing but referential integrity. That is the meaning of what? Referential integrity. So foreign key is used to maintain a term known as referential integrity. And whenever you're talking about a foreign key, whenever an interviewer is asking you about foreign key, the word known as referential integrity should always be a part of your answer. This is a necessary keyword which needs to be mentioned and which needs to be explained into your foreign key ka definition. Now, I'll explain you in detail what is the meaning of referential integrity, why it is important, and how that helps you to maintain the data flow very effectively. So, as I said, a foreign key is an attribute or set of attribute, which means you can have one foreign key, you can have multiple foreign keys in a table, which create references within the table to maintain referential integrity. Now, as I have said, there is a word known as referential integrity, but what is the meaning of integrity? What do you understand by something called as integrity? Let's try to understand that. So, let me first make you understand something called as data integrity. Now, imagine there is a product. Imagine today I want to buy a phone, and I'm buying a phone of Samsung. Let's say I'm buying a phone of Samsung Flip 5. I want to buy a phone over here. Now, if I want to buy a phone, it's not like I'll go to one particular website and then buy it at random. No. I do a lot of checks at different websites, and then and only then I'm going to buy. According to Indian mentality, that wherever I feel so, okay, this price is less, this is my good cost, and this is where I'm going to buy. So imagine that my product which needs to be bought is what? Is Samsung Flip 5. And I go to 3 different stores. First, I visit Amazon. Everyone's favorite site, Amazon. Now when I go to Amazon, the cost of this phone is, let's say, 190,000. Imagine. Now it's a rough estimation, it's not an actual cost. So let's say the phone cost is 90,000. Now definitely I'll not go on Amazon directly, put it in cart and buy it out. I'll go and check on Flipkart. Correct? Now you want to get a good deal, so you will definitely go on Flipkart. And on Flipkart it is showing me, let's say, 89,000. So I feel so, okay, 89,000 is lesser than 90,000. Let me buy from Flipkart over here. So I can think of buying from there. Now imagine that tomorrow I don't think so, like Flipkart and Amazon where I'll buy. I'll just inspect once in Chroma. So there is a Chroma showroom near me. And I went over there and there was a discount offer at that particular time and the phone is costing me around 85,000. So if you can see, the phone brand is Samsung Flip 5 and at Amazon it is costing me 90,000, Flipkart 89,000 and Chroma 85,000. So do you think so the cost is same throughout? No. The cost is changing for different sites. For different databases the costs are changing. So here when I talk upon integrity, the word integrity, just a second. The word integrity means same throughout. Just a second, let me change the color. Yeah. The word integrity over here means same throughout. Means the value of the data should be what? Same. There should not be any discrepancy in terms of value matching. So if you can see Samsung Flip 5, in this database it's 90,000, Flipkart 89,000, Chroma 85,000. So it's not same throughout, which means there is no integrity into the databases. And definitely the databases are two different platforms and that might not have integrity over here. But when it will be into integrity, let's say it was 90,000, it was 90,000 over here and it is 90,000 over here. If that was the reason or if that was the case, the data would follow an integrity. Now, I hope you are clear with what is the meaning of integrity. Now, integrity means the value should be same. I am not going to do a data integrity concept, but I am going to make sure that you understand what is the meaning of referential integrity. For that, you need to know the term known as integrity. So, integrity is nothing but same throughout. So, as we have done so far, so with this outcome, I can say yes, my data is into integrity. But let's talk upon the main term over here. What is the meaning of referential integrity and how it will be helpful? Imagine now a student who has enrolled as per my data engineering part, he or she would be allocated with a course. Now let's create another table known as course. So I've created over here and let me create a very small table. I just created here itself so that you will all see. So I'll create a very small table over here known as course. Now in this, let us have some names. So this table is what? Course table. And here I have a course ID. I have ID of the student and I have the course name in which the student has enrolled. Let's say this is the data which I have. Now I want to say that this table and this table is related to each other, which means the student who has enrolled, that student would be allocated with the course. That kind of information I want to give. First, when I am creating a table, let's say this is a table which I have created and course ID and course name is a column which I have. If I want to join this two table or say that there is a relation between two tables, I need some common column between them. But you can see there is no column with the same name. So can I have a common column between them? It doesn't seem it's possible. Why? Because the name is not same. But it doesn't matter, the name needs to be same. The thing that matters is when a relation is created, that is the data type and the column or the data definition needs to be what? Same. So if you can see your ID and your student ID. Now what is this course table? It will consist of course ID, the student who is doing the course and the name of the course. So if I want to join these two tables on the basis of student ID and course ID, student ID and ID from the course table, I could possibly do. But imagine that when a course table was created, this is not a foreign. So I am giving it as varchar. Let's say it's varchar. ID is a primary key, being integer, okay? And here the name of the student is a varchar. I want to study what? I want to study a foreign key. Where did I create a foreign key? I know that the student ID of this table and ID of this table needs to reference or needs to create relation. But did I have created any foreign key to make a relation? No. Now why do you think so it's important? Now keep this pointer in note that references. Now this is a note which you all need to remember, that is references or relations. References or relations within the tables, which means when I have created references or relations within the table would be between a primary key, I am writing a short form as primary key, and foreign key, which means whenever I am referring a table or I am creating relations, it needs to be maintained between one primary key and one foreign key. That is one of the major requisite over here. Here I know that this table has a primary key. I know that this table has a foreign key. But where is the foreign key? I don't see anywhere. I can see two primary keys which are there. Now remember one point as well. In order to reference to another table or relate to another table, a column or any of the column can act as a foreign key. Now foreign key doesn't have that requisite that it needs to be not null and unique. It can be repeated, it can be having null values as well. So my foreign key can have those concepts. So here it is a primary key, but I want to create a relation, so I will make it as a foreign key just to create a relation. Just in order to create a relation, I am going to make it as a foreign key. So just observe that how the relation is being created and how the referential integrity is maintained. So I will say that this table is having a foreign key known as ID, which is going to refer to this table, which means it is going to look for students table, and then and only then the data in this table is going to be filled. So I will create a relation in such a way, just a second, in such a way that this table is referred to this, and you can see this table is referring to this table. I've just given one demo arrow over here that this table is referring over here. So foreign key is what? Foreign key is my this column ID, which is taking references. So foreign key is an attribute or set of attribute which helps you to create references, means referring from the another table or within another table which is there. So a relation needs always be created between a foreign key and a primary key. I hope it's clear with you all that how a relation is being maintained. Now what is that relation called and how we can justify this relation, how this reference will help you to maintain referential integrity, that's what we are going to study over here. So as you can see that there is a relation created between one foreign key and a primary key. And you can see foreign, which means coming from outside. This relation is coming from a different table over here. So this is a relation created. Now what is there? A table where you have a foreign key is known as referencing table. Now, what is the meaning of referencing table? Referencing means referring table, which means this table is going to take references or some kind of checks from the students table. Unless and until the checks are being made, no entry is going to be filled into the course table. Now what kind of checks? Let's try to understand that as well. So this is known as referencing table, and in the relation which is created, a table which consists of a foreign key is known as a child table. And one primary key can relate to multiple foreign keys, which means multiple tables can be related to that one particular key which is there. So if you can see, a relation is being created. So this is a child table. Now this is a referencing table because this table is going to refer something from this table. So a table where a primary key there in the relation is known as a parent table. It's a parent table, and it is also known as popularly referenced table. Now what is the meaning of referenced table? Which means this table is being referred, this table is being utilized to fill something in another table. So that is the meaning of referenced table. So I have a relation between a referencing table which is referring and the reference table which is letting it to refer, which means letting it to look. Now, as I have shown you some technical word, let me help you to understand it in a more detail. Now imagine this is the relation which is being created, and I'm trying to fill in the details over here. Let me add the details over here. And I say the student ID is 101. The name of the student is Raj. The age is 24. Let's say city is Mumbai, gender is male, and the phone number is something. Now let's say I give as 102. So these are the students who have enrolled, and let me give the name as Rashi, and the age is 25. Here she belongs from Pune. The gender is female, and she has some number which is there. Now let's say I add 103, and here the name is, let's say, Joy, now 24, and he is belonging from Bangalore. The gender is male, and the phone number is something over here. And let's say there is another student who has enrolled, 104, and let's say I give name as Eric. The age is 25. He belongs from Mumbai, and the gender is male, and here I give some random number over here. So here you can see these are the students who have enrolled, which means who have inquired for some or the other courses which are being sold into the Imarticus part. So their data entries are being created. So each student has a different or a unique number which is known as a student ID, which is acting as a primary key. Now all the students definitely who have enrolled is not going to take the course. They are not going to be the part of the course. Now 4 of the students came an inquiry, and the details were created into the Imarticus ka student database. The students have enrolled. But course enrollment is not done by all of them. Let's say I have course as C1. It is being done by 102. And the course name which they are doing is what? SQL, which is correct according to the relation. Why? Because this table, when the data is being entered, is referring. What is the meaning of referring? Means it is looking out. Is it correct or incorrect? So here you can see ID to ID, this reference is being created. So 102 and 102 over here. Is there an ID match? Yes. So reference is being created. So when 102 course allotment is done, it is definitely saying yes, you have been a part of the students, and then you can get a course. SQL is being done. Let's say I give C3 as a course to 108 and Python. This entry is going to have an error. It is not going to be entered. Why? Because you can see reference between ID and ID is created. What does ID say? 102, 102 match is being found. 108, when it is trying to enter, then it is referring to students table, which means looking or checking or validating with the students table. 108 as an ID is not there. Obviously 108 ID is not there. How come that student is doing course? It could not be possible. And when you try to enter this entry, it's not going to show any outcome. It is definitely going to show error. Why? Because the entry of the child table is not matching with the parent table. This is a major important of references or relations which are created between two tables with the help of a foreign key and a primary key. Why it is called as referencing? Because every time it is having something, it is referring to the main table where a primary key is there. It is also known the parent table at that particular instance, and it is checking the integrity. If you can see 102, 102 fine, but 108 and no 108, there is no same value, so there is no integrity. So when you create reference and when you try to check is the value same, in order to maintain referential integrity, here it's not being maintained. So referential integrity over here would be ruled out and it is going to give me an error. This is the meaning of referential integrity. What does it say is that when a foreign key table is referencing to a parent table or a child table, it will try to refer or it will try to maintain the integrity, that is the same element based on the relations or the relational column which is being used. The table which is taking referencing is your course table and the table which is being referred is your parent table, and both of them are helping us to get a referential integrity maintained, and this is how the data flow would be kept the same. So as you can see that I have created a reference between a foreign key from my course table and a primary key from my parent table, that's my student table. Now parent table being my main table from where the foreign key is going to take referencing, which means refer something in order to fill. Now as you can see that when I was trying to fill 102, it was able to be filled in. That student is getting allocated with the course. So referential integrity is maintained. But when I tried to fill in the course details for 108 as a student, and that student is not being matched from the base table or the reference table or my parent table which is there, so that integrity was not being maintained and that kind of record is not being entered. If the relationship between primary key and foreign key would not have been created, 108 as a course could be added into my data and that can cause some data discrepancy. How? That 108 as a student is not available, then how come that student is doing a course if that referential integrity was not being maintained? So this is how referential integrity or the references between primary key and foreign key is important. Now I wanted to show you a little detailness about those references which are being created and how the data flow would be maintained when we try to insert some data, when we try to update some data, or when we try to delete some or the other elements over here. Let's try to understand that in detail, that how this referencing is going to deal with a parent table and with a child table. So imagine that there are two types of tables which I have. The very first over here is my referenced table. Now you all must be knowing my referenced table over here is nothing but my parent table. And there is something called as a referencing table. Now what is a referencing table over here? The table which is referring some value, that is a child table which I have, And I wanted to show you that how the referential integrity is maintained and what are the new key aspects which are added between these references when are those created. So imagine that I have a data and I'm trying to insert some value. Now what is the meaning of inserting a value? Adding a data points over here. So where I am adding a data points is reference table. That is my parent table. Now which one is my parent table? If you can see, this one is my parent table over here. Now imagine there is one more student who has enrolled and the ID is created as 105, and let me write the name of that student is, let's say, Raj again. And here you can see age is 24, he is belonging from Mumbai, gender is female, and some number is 992. So phone number is different, but if you can see, rest of the detail seems to be same. So these are not two duplicate entries because of the ID, it has made it as unique. So when I try to insert any data into my reference table, that is my parent table, it is not showing any errors to me. Why? Because n number of students can enroll or n number of students can at least log in or registered into the student database. For an example, let's say you go on Amazon. It's not mandated that you have an account on Amazon, then you have to order as such. Many people can just create the account, be the customer of the Amazon database, but might not buy anything as such. So here also n number of students can come, inquire, create their data entries, but it's not mandated that all the students are going to be allocated with the course. So here if you can see, when I'm inserting data, which means I'm adding data into the reference table, it is not going to cause any issue. So I can say no problem means no issues, or I can also call it as no violation. Now what is the meaning of no violation? No violation means that the data is not going to have any of the problem when the data is being inserted. So n number of records can come and be inserted into my parent table, that is my reference table. Now let's talk upon update. Now imagine that I'm going over here and I'm updating some data. Now what I'm updating? Imagine the ID which I gave for one particular student, I don't want that ID to be followed. I want it to update. So let's say when I gave ID as 103, I want to update this as 106, which means the student ID. Now this update is with respect to the integrity constraint. Now integrity is maintained by IDs and IDs. So here if you can see 106, the ID is being updated. Is there any issue caused over here for me? No, because there is no such record into my child table, that is into my referencing table. So there is no such violation. But what if I go and update the ID of 102, which is Rashi, and I update it as 109? Obviously, some integrity constraint would be hampering over here. What it could be? As you can see on my screen, now 102 has changed to 109. But is 102 changed over here? No. So what does this specify? That when 102 is doing course, but in my students table, can you see that 102 is doing course or 102 as a student has been enrolled? No. You cannot see that 102 as a student being enrolled. So does the integrity is maintained or is it same throughout? No. Why? Because 102 as a student is no longer into my database. How come he or she is doing the course? Which means 102 over here needs to be validated or needs to be changed at the same time, or may not this update is possible. So what is this called over here? If you can see, when I did updation, let me repeat it again, that this is the student, these are the students. Let's say I say 103 that is Joy's ID, I want to change from 103 to 106. I've changed it and there was no problem. Why? Because it's not available into my child table. That's fine. But when I go to Rashi, that is 102 as an ID, I'm not going to change anything. If anything else changes, it's fine. But ID and ID change, that is not fine. So 102 as an ID, I'm changing to 109. Which means 102 as a student is no longer there into my system. It has changed to 109. But if you can see my course table, that student is still doing a course. Can you think that 102 as a student is no longer into my system? How come that person is doing a course? That's hampering my integrity rule. That's hampering my referential part. So this kind of update or maintaining the relation and updating a data into my reference table when the data is also available into my referencing table may cause violation. Now why did I say may cause? Because when I did 106 there was no limitation or there was no violation, there was no problem for the database. But when I did 102, as it was a part of my child table, the reference was maintained, it was causing a problem. So what can we do to avoid that kind of problems? So there are solutions for the same as well. But when I am doing update, as I said, it may cause problem, may cause what? Problems or violations. Let me write it in a proper term, that is violation. What does it mean? That means when I'm trying to update at one particular part that is into my parent table and the same integrity part is available into my child table, this update would cause an error. It will give you restriction. So what you can do to avoid that? One thing which you can do is Cascade. So they have rules known as Cascade. Now what is the meaning of Cascade? Cascade means all at once. Means it will happen simultaneously. Now if I go over here and talk upon Cascade, let me talk. That is, if I am updating 102, which is also a part of my child table 102, if I am updating it to 109, if the value which is updated at parent table is available into my child table, that also gets updated at the same time. So 109. Now the integrity is maintained, there is no violation into the rule. So in order to avoid the violation, we can do this task. That is, we can update the data over here with the cascade. Means if it is updated in the parent table, the same value if found in the child table would also be updated. That's the meaning of cascade. One of the solution to avoid this violation, just a second. Yes. So if I go further over here, so cascade is one of the solution which we can add, or we can add something as set null. Now set null as an option is something which is not so much valid, not so much used, but it's one of the option which you can use to avoid this violation of the rule. How? If you go over here and imagine that I'm updating 102 to 109 and 102 is available into my child table. In order for doing this, I can set this value as null, which means the value at that particular position into the child table would be set as null. Now no one has said that foreign key cannot consist of null. My foreign key can be null, unique, or null, repeated, or can be not null. There is no such restriction that foreign key is supposed to be not null and unique. No. But if you see over here, this option is not a valid option or a good option. Why? Because it's just a foreign key to create relation. But for the actual table, it is acting as a primary key. Can primary key be null? No. So this option might not be a fruitful option over here. So set null as an option, which means if a value is updated in the parent table, if the value is available in the child table, at that position the value will be set as null. But if you can see in our case, primary key was the base table column for that particular value, and it cannot be setting it as null. And setting any value as null is not one of the good option which we have. So this is there, and the default option which is no action, or I can call it as restrict. Just a second. Or the default option which we have, which is no action, means nothing will happen, or one of the major one, that is restrict. Restrict means it will restrict the approach, which means it will give you error, and that's by default available, which means if you don't say that you want to cascade, if you don't say that you want to set null, then if the value which is updated in the parent table is available into the child table, that updation would be restricted. It will throw you an error that updation is not possible because of the referential integrity being maintained between both the tables. And this is how you can avoid the may cause violation rule when the update is happening from a parent table to a child table. So this was about the update, and then let's talk about something called as delete. Now what is the meaning of delete? Obviously, if I want to delete some row, delete some record, how it could be possibly there? Imagine that student 105 has cancelled the admission, has never took a course, and I just eliminate his record from my students table. Is it going to hamper anything for my child table? No, there is not going to be any hampering part over here. But if I go and eliminate 102's entry, obviously it is going to hamper. Why? Because 102 as a student is no longer part of my database, but she is doing a course, and that's not possible because the student is not there, the student entry is gone, then how come she is doing a course? So that is also going to cause a violation, which means if the information in the parent table is available and it's being deleted, which is also being part of child table, this is going to cause a violation over here for us. So this also, just a second, yeah. So this also is going to cause violation. So this is also going to be may cause violation. Now what can I do to avoid this? The same rules over here which are being implemented. That is cascade, set null, and no option. Now what is the meaning of cascade over here? Now cascade means if the student entry is eliminated from the parent table and the same student is available in the child table, it will also eliminate it at the same time. That is the meaning of cascade. Then set null, as you can see, that if the student entry is eliminated from the parent table and the same student is available in the child table, that value or that position will be set as null, which is not ideally good choice. And then I can have something called as no action and restrict. I'll show this with a practical example that how does cascade works and how does restrict works. We will be creating the database which we are creating as a data engineer for Imarticus, and I'll show you all those options over here. So when a referential integrity is maintained, in order to avoid this issues, this is how we can try to use more options into your referencing. So this was all about the parent table referencing, which is being there, that is a reference table. Now obviously I am going to insert data into my child table as well, because that also needs to be filled. So what kind of rules or what kind of limitations I can do set over there? So let me change the color over here, and obviously I will be inserting some data into my child table. So I go and I try to insert some data. Now what I'm inserting C2 over here, that is a course 2, and 102 which is there, I'm inserting 104. Is it possible for me to insert? Yes, C2 is my Python, so I've inserted that over here. Imagine that I insert C1 for 1110. and then I'm giving the course name as SQL. Do you think so? C1 will be allocated to a student ID named as 1110. Will it be? The answer is no. Why? Because there is a referential integrity, and when 1010 is being entered, it's not there into the student base. So how come that student is getting the course? First enroll and then the course would be allocated. That's what you know. That this is an issue which can be cause. So can n number of records be inserted into my child table? No. There is a referential integrity being maintained, which means only those rows will be entered which are a part of my parent table. N number of rows or any IDs cannot be inserted over here. So this is also going to may cause violation. And we will see all of them with a practical example for the same. So this is also may cause violations. And then let's try to update. Obviously, update if I am updating something over here, which means let's say if I am updating 104 to 105 and 105 as a student is not available into my table, obviously we have to do something. So this is not going to update. So 105 student entry, don't you think so? It will not be created. Cascade would not happen. So 105 only would be created. Rest all entries would be empty. You can do restrict. You can do restrict over there. That is when you try to update into the child table and it's there a part of my parent table. I can restrict that the update in the child table would not be possible. So this is also going to cause violation for us. So when you try to update the data based on the references, that is also going to cause violations. So may cause what? Violations. Violations over here. Just a second. Yeah. So that is one issue which you can see. And let's talk upon delete in terms of referencing table. Now the student has done with the course. The student has completed the course. Do you think so that course detail meets the requirement of that student? No. So 104 has done with the course. Is it a problem to eliminate? No. There is not going to be any problem if I delete n number of rows from the child table even though they are part of my parent table. So delete is not going to have any problem. You can delete all the rows or n number of rows from your child table. So no problem, I can say, just a second. Yes, so it will say no problem or no violation which is being caused. So no problem or no violations. Now this all the things which we have seen theoretically, let's try to understand things on a practical point of view as well, where you'll get to see how does a cascade work, what are the references which are applied, and how those restrict, no action and all those things will be actually taken care of into the relational databases to maintain the referential integrity over here. I hope you have understood the part about reference table and a referencing table and how a reference is being created between them. Let's see with a practical example by creating actually this references between the table of students and course, and let's see whatever we have discussed theoretically, is it practically implemented or not. So this was about a foreign key with respect to referenced and referencing table, and these are some issues which could be created when we try to insert data while maintaining the referential integrity, and there are certain solutions for them, that is cascade, set null, no action or restrict. So if you can see on my screen, when I talk about foreign key, so foreign key has 4 reference options. One is cascade, one is set null, one is no action, and then there is something called as restrict. So cascade, if a row from the parent table is deleted or updated, the values matching to the child table rows in the child table automatically gets delete or update, which means if you're deleting or updating the values from the parent table, if the matching row is found into the child table, it will also be deleted or updated. Then there is something called as set null. If the row from the parent table is deleted or updated and the same value available into the foreign key column, now it's in the foreign key, not in the entire table, only the foreign key column will be set as null. Now restrict, if a row from the parent table has matching row in the child table, MySQL is going to reject, which means that is not going to happen. No update, no delete is going to happen over here. So let us try and see how a course table is created, how a reference between both the table is created as we saw on the screen on the whiteboard. So here I am creating course table. So course table, I'm just giving a comment over here. So how do I create? If you can see on my screen, just a second. So I'll do create, as you know the syntax, create table. Create table what? I'm creating a table known as course. And in this course table, as you can see, this is how the syntax follows. Create table, table name. And you have to give a parenthesis where or a round bracket in order to add the names of the columns. What is the names of the columns which I have? The very first is course ID. And I'm going to give it as a varchar. You can give anything, so I'm giving it as varchar. Now you all know what is varchar. Varchar is a data into a string element where it will consist data of a variable character. I give it as 4. So 4 is the character, which means the maximum size it can consist of character is 4 over here, and I want it to be manded. So I write it as not null, which means I want all the course IDs to be there whenever a new data is being inserted, comma. Now I'm creating an ID. Now remember, when you're creating references from a parent table to a child table, now my parent table is my students table, my child table is my course table, which means child table, that is a course table, is going to refer from my students table on the basis of what? IDs as a referencing column, as a relational part. And for that, in order to create that, you have to make sure, even though the column names are not same, but the data type is same. That is one of the mandate check which we have to do. The data type needs to be what? Same, even though the column names are not same. It doesn't matter that the column names are same. So I'll write int over here, and I will make it as a primary key. There is no such issue that a column which is acting as a foreign key cannot be a primary key. That foreign key relation is only for the references, nothing else. So primary key, and after that I give that column as a course name, and I give it as varchar, and I give it as character as 20, 10, whatever I want. So I'm giving it as 20. And I want it to be not null again, so I want this to be mandate over here. Now how can I create a foreign key? So foreign keys are not created in this manner, that primary key and just you write over here as foreign key. No, if you write in this particular manner, obviously it's not going to make any help or any issues or any reference or relation over here. The foreign key is created at the end. So here you can see after comma, I write something called as foreign key. So here you can see foreign key is being created. So there is an error. Now what is this error? You can see statement is incomplete, expecting an identifier. Now foreign key, you want to create foreign key which column or which part of your table. So which attribute you want to act as a foreign key. So I want ID to be acting as a foreign key. It is just for reference, not for a temporary purpose. The nature of ID is still a primary key. It's an integer, but just to create the relation or the referential integrity maintenance, this is acting as a foreign key. So ID over here, and then where it is going to refer. So this table is referencing, the references. what? Students table. Now you have to check the name. You can see the name of the table which I have is students. So students table, which column it is referring is student ID. As you know, this is a child table from where the foreign key is coming, and you have to give the references. So where it is referencing students tables, students ID. As you saw on the board, the same relation is being created over here. So as you can see, just a second. As you can see, this is how I created a relation. So this is a referencing table which is referring to a students table, and that is being maintained. So if I don't pass any restrictions or any rules, it is going to restrict all the update and delete part. But I am writing on delete, which means when data from a parent table is deleted, I want, if it is possibly available into the child table, that should also delete. So on delete cascade, and I write on update, I can write restrict. So I've given restrict means on delete it should cascade, means if it is deleted from the parent table, if it is also available in the child table, that should be deleted, and on update it should restrict. And this is where my query ends, and you can see there is a reference created, and I just have to do control enter, and you can see the row is being affected. If I go and refresh my table, go into the course 1, and here you can see a foreign key is created, and if I click on that, you can see foreign key, and it is targeting to what? The referencing to what? Student ID. On update it is going to restrict, and on delete it is going to cascade. And this is how, with respect to code, you can create a foreign key, and you can create the referential integrity between your two tables. So as you saw now, with respect to the theoretical aspect, that what is referential integrity, how a reference being created between the two tables with the code, as well as how the reference would be maintained. Definitely, when we proceed further, when we try to insert, update and delete into this particular data, we will be seeing that how these references are actually molding and actually helping us to store a relevant data, and the data redundancy issue which was there, which means the data discrepancy which was there earlier would be avoided by maintaining the referential integrity. So if I want to talk upon the primary key and foreign key which we studied over here, you can see primary key versus foreign key. Now this is one of the most important question asked, and this is one of the most important topic which people wants to know and wants to understand in detail, that why do we need a foreign key and why do we need a primary key. I hope I solved your questions. I hope I solved and gave answers for all of them, but I would like to show you the difference between both of them. So primary key, it must contain unique values. As you saw, that primary key is a combination of not null and unique, which means all the elements should be distinct from the another, which means each record entry should show different element or a different value. So it must contain unique, but it's not a case in foreign key. You can have duplicated entries as well. In the further part, we will be creating more tables, we will be creating more references, and in that I definitely show you that foreign key can contain duplicate entries for the same. Now, it cannot contain null values. Yes, it's sure that your primary key cannot contain a null value. Here, in foreign key, it can contain a null value. As you saw, one of the rule, one of the restriction, one of the references, that when the value is deleted from the parent table, if it is available into the child table, set it as null, which means it does accept null value into it. So there is no such restriction, or there is no such rule that foreign key is going to be unique and not null. It can be unique and not null. It can be repeated and null as well. So it can contain null values. A database can have only one primary key, which means in your table you can have one primary key. And a database can have more than one foreign keys, which means in a table you can have multiple foreign keys as such. A primary key is used to identify, which means when I want to identify that each record is different or unique from the another one. In order to add that distinctiveness or the uniqueness, primary key is used, and it is used to make relation between the two tables. Foreign key is not just for a temporary purpose or not just for creating purpose. It is helping you to maintain the relation, the references between the two tables when the data is being entered, and it assures that a good set of data being entered without any discrepancies over here. So as you can see, this was a primary key and foreign key, and these are the two major keys which are asked the most when we talk upon the relational database management system, or we talk upon the relational databases. So I hope you understand what is a foreign key, what is a primary key, and how both of them can create relation with each other. In the further part, we are going to understand that how more relations would be created, how multiple foreign keys would be created, and how the data insertion or the referencing relations which we saw theoretically would be implemented practically, and how does Cascade and all works. So I hope we are clear with this concept.